All right, guys. Okay, thank you very much for coming. My name is Marek Osicimski, and I'm Golem's Chief Communications Officer. And yeah, really, it's so great to see you all here. It proves the notion that Berlin is such an exceptional city, a city of decentralized technology enthusiasts, a city of Ethereum enthusiasts, and last but not least, the city of Golem enthusiasts. And even if you, yeah, that's right. Yeah, we can give all a round of applause for ourselves. So, go ahead. Yeah. And even if you don't share this notion, this status of an enthusiast, of a Golem enthusiast, I'm sure that right after this meetup, you will leave this place feeling as one. Let me just tell you briefly that we are really caring about the certain interaction with you. So after each speech, there is going to be a Q&A session. So please ask questions. I'm sure our speakers will be delighted to answer many of them. So right now, let me present to you Julian Zawistowski, our CEO, Golem CEO, who's going to describe or explain the very idea that stands behind our title, Golem and Friends. Julian, the floor is yours.
Thank you very much. Again, hello everyone. Thank you for coming. And thank you, Blue Yard, for having us here today. I would say that Blue Yard is the very reason we are meeting here today, because some time ago they asked us if we would like maybe organize Meetup in their space, and we said, yeah, why not? This is actually a great idea to have first Golem Meetup. So here we are today to tell you more about Golem and tell you more about Friends. And we decided to use this formula because at some point in the past we realized that building Golem is really hard. And it's really hard not in the places where we thought it would be hard. Of course, it is hard there. But also in some other places where we hope that it will be not that hard. We are on a good path now to the first release, first production release, which will happen when it is ready. And I'm sorry for telling you that, but this is like what we always tell you when you ask about that. I think that this will be a gradual process. So you will see when this will be coming closer and closer with the closing, the issues with the growing functionality. But I think we are on a path now for delivering that in foreseeable future. And we are going to do that on ourselves as a Golem team. And the first presentation today will be by Piotr Janiuk, Golem CTO, and Aleksandra Skrzypczak, lead developer of Golem. And they will tell you more about our plans for the near and short-term future. Then, because things we are working on are hard, we believe that cooperation is something that will advance not only Golem, but the whole space. Therefore, after Golem presentation, we would like you to learn more about two very interesting projects that we are cooperating with, Streamr and Qubes OS. Our cooperation with Streamr was announced some time ago. We believe that what Stream is after is something that could become medium-term use case for Golem, which means that on the way they will have to resolve many issues and problems that would have to be resolved for Golem in general. Therefore, this cooperation really makes sense. What we are going to work together on will not make it into the first production versions of Golem, but long-term this cooperation is important for the advancements of Golem, Streamr, and hopefully the whole space. So right after Golem team, Henry Picala from Streamr will tell you more about Streamr and how it overlaps with Golem. The second presentation comes with an announcement, and I'm announcing that at that very moment, that Golem is going to work with Qubes OS on long-term solutions that will increase security of both Golem and Qube OS, Qubes OS, regardless of if we are going to enhance that cooperation to something more in the future or not. We believe that there are overlaps in a security that makes our cooperation a chance for both parties. And Qubes OS is represented today by Joanna Rutkowska, security researcher focused on security of OSs, and also founder of Qubes OS, which is reasonably secure OS, probably more secure than anything around, at least according to Edward Snowden, as far as I know. And that would conclude the part with where we want to present you projects that we are directly cooperating with right now as Golem. This will be shortly summarized by Grzegorz Borowik, one of senior developers of Golem. Second part will be a bit more general. First, we will start with Vansa and Thomas' presentation of OmiseGO project, which I'm sure all of you know as one of the most important and most interesting projects in Ethereum space. And I would like to make an announcement that we are not merging with OmiseGO, and Golem is not directly cooperating with OmiseGO. I stated that on social media many times over the last week, but just to make sure, this is not what this is about. Indeed, OmiseGO works with IMAP, so company where Golem was born 3 years ago, but this is not really like a partnership, but simply IMAP is contractor to OmiseGO, one of the parties to help them to bring OmiseGO project to fruition. That said, of course, there is overlap in technology stack, and this is one of the reasons why OmiseGO is that interesting project for IMAP. And one of these overlaps, probably most profound, is scalability of Ethereum that will be needed to fulfill the great dream that OmiseGO for banking the unbanked. I'm sorry, to deliver OmiseGO, and this scalability issue might be solved by Plasma, which is a concept by Vitalik Buterin and Joseph Poon, which will be presented by Joseph to conclude our meeting today. So I hope you will enjoy. This is all from me, and yeah, thank you.
Okay, thank you very much, Julian. And as Julian just said, I would like to now ask to the floor Aleksandra Skrzypczak, our lead software engineer and co-founder of Golem, and Piotr Janiuk, our CTO and co-founder of Golem. The mic and the floor is yours.
Okay. Hello.
Hi.
Just introduce yourself.
Yeah. Okay. I was already introduced, so I don't think that there's more point of it. For the most presentation, I will switch the sides. So.
Yeah. And hello, I'm Piotr Janiuk, Golem CTO, and we are going to give you a brief recap of where are we now, where we are now, and what we plan to do, and how Golem may be utilized, starting from Brass release, and even from the technology that we have right now. So, let's please. I'm sure that all of you saw this diagram at some point. If not, then this is the introductory diagram of Golem, meaning that it's a prosumer market of computational resources. And what we started with was a platform when those resources can be exchanged. So we have requesters, we have providers, and in fact we have developers who deliver some software, but at this point we want to focus on just delivering the platform where the software can be run. If you can. Yeah. So right now we focus on sharing compute resources, and providers just provide hardware, CPU power, raw CPU power, no additional resources. This is something what is a core of Brass Golem, which is important because this is only brass. We're going to do much more. But right now we focus on exchanging CPU power. Just to give you something you can play with, we decided to, as you know, implement Monte Carlo rendering on open source renderers. And namely, this is Brass, this is Lux Renderer, and Blender. And up to this point, we're pretty certain that we know everything and we know how to solve everything. So the Brass Golem may not be out just yet, but as for the problems, there are no problems, no obstacles that we don't know how to solve. So everything is in place. We just need to spend a bit more time with the groundwork and developers' work just to provide it and deliver it. But there is absolutely nothing we are even uncertain of how to solve. So let's take a step back. And having said that, we need to focus on providing something more, because we know what to do with Brass. We would like also to use this technology later on to something more. As you know, Golem in its current incarnation is a system which can be used to conduct and MapReduce computations. And as you can see, there are quite a lot of use cases which can be solved. Monte Carlo, for example, renderers, or maybe computational chemistry, graph traversal, especially large graphs which are computationally bound, and it may apply to, for example, biology. Monte Carlo also can be applied to material physics. Machine learning is a broad, very broad and vast area where quite a lot of cases can be shown. So we're going to show you how a few of these examples can be implemented in the Brass framework. Not the Brass itself, but the technology that Brass is providing. So, the graph traversal. This is very easy to define problem, but if you would like to traverse a large graph where each node requires quite a lot of computation, then even though you may introduce some redundancy, distributing this across network or different nodes may be very beneficial to your solution. So we state this. Can you also press one more time, please? Thank you. We state it this way. For each node, we would like to call a function, f, which takes input parameters, parameters associated with current node and the node itself, which results in candidate nodes, in those C nodes. And for each node, we just evaluate a function and just traverse it using a requester, well, a node on which we process it. The point is that if you would like to do it more efficiently, you need to be able to easily distribute this across the network, which is obvious from this picture. Yeah. So it's a good fit for Golem and MapReduce framework, where you can distribute this work easily across many nodes, and each of these nodes computes optimal path of length m. So this may be longer than one, but to make it feasible and to make it efficient, you have to merge subpaths and make sure that all nodes calculate valid results. So you require a very, very good verification scheme here. If we talk about Golem, then paths which are too long may be difficult. But if we talk about Golem right now and it's Brass, then we can easily use the framework that is used with rendering. So for the current incarnation of Golem, MapReduce requires that we only find subpaths of length 1, which means that we only move one step and send back the results. Verification is exactly the same as the framework used with rendering, which is, by the way, pretty well described. We were going to announce it shortly, so you can expect both the document and the Medium blog post. And optionally, because we don't try to make it optimal, we can require providers to cache results so that they don't have to perform too many computations that are not necessary. And let's say that this works, that Golem evolves as you wish. Then this problem can be implemented even better and more efficiently. First of all, MapReduce can be used with subpaths of arbitrary length, not one, which was stated in the previous slide. And even better, we can move to microservice approach, where you simply call a microservice, which is a stateful process, and ask it to compute for you. And the microservice can then dispatch the computations to the Golem network itself. Again, it's not your problem. You just ask the microservice to calculate it and get the whole result. And that's it. From this pretty generic statement, you can really implement computationally bound graph traversal. And now Alexandra is going to give you a brief introduction to machine learning.
Yeah, now I would like to present you something that our great colleague Jacek was working on this summer and is trying to prepare a machine learning proof of concept. So why do we need machine learning? Let's imagine that you are a crypto trader, you want to maximize your profits, but it's difficult to predict the future. So every additional piece of information counts. So you may want to do some sentiment analysis on the media. And you don't want to spend all your time on the internet, so you want to automate this project and train a classifier that is going to make this for you. For example, you can use a neural network to do this. And you want to do this on Golem. So you have to ask yourself the question, how to distribute computation and how to verify them. So let's start with distribution. Unfortunately, training neural network is a sequential algorithm. So it's not something that can be easily distributed. It can be done. It is sometimes done on some clusters, but there is low latency, and it's not a good use case for a network that is worldwide spread like a Golem one. But what can be easily distributed is hyperparameter tuning. Hyperparameter is something that describes the general state of the network, like how many hidden layers are there, or what is the size of the layer, what function are we using. Okay, so for all of you that missed the first part of the talk, Vigit was generally talking how to implement NAT traversal on Golem, and I was talking how to implement neural network training on Golem, and that you can distribute it, not full neural network training, but hyperparameter tuning. Okay, so let's leave this distribution behind and talk about verification. As it was mentioned before, it's a sequential algorithm. Each block on this picture represents one iteration. And we want to use exactly the same framework that was used for brass drawing and for NAT traversal, local verification, probabilistic local verification. So you want to check small part of the computation. And by small part, in this case, we understand single iterations. More iteration you check, the higher probability is that the full data is correct. So provider pre-commits the hashes of the state after each iteration to requester. Then requester asks him about some random iteration. And provider is supposed to send the full state. Requester repeats this single step and check if it's correct, and it hashes to this pre-committed hashes that was sent before. If we additionally somehow randomize these input data that are there, for example, by doing some permutation of batches or different subset of batches that are known to both sides, we can be sure that there are no cycles in this data. Yeah, that's quite a complicated topic, so if you have some additional question to me, please ask after this talk or send us an email. And now I'm giving the microphone back to Vigit, who's going to talk about licensing.
Yes, thank you very much. If you please. Okay, so we addressed this part, the framework part, when we have requesters, providers on the platform, but we left out our poor software developers, and we really need them in our solution. And Golem, this single part is one of the most important parts in this project, so we really take care of how to integrate software developers and proprietary software into the Golem. So, right now, we start modestly. We just would like to allow software developers to easily integrate software licensing solutions into our framework, so that it's very easy for them, and so that their existing architecture doesn't have to be changed at all. So this is the prerequisite. We need to address those two things, but to integrate it with Golem, we have to prepare a bit more. So first off, we need API for existing solutions for software providers, so that their frameworks can contact and interact with Golem network. And at the same time, we need to enhance Golem protocol to interact with those special nodes. And this may be license servers or license infrastructure, whatever it is. By the way, we're going to announce, first off, announce a Medium post about this protocol enhancement, and then provide you a document with detailed protocol specifications so that you can evaluate it yourself. And additionally, we would like to provide some logic for those servers. It's optional, but it should allow those software developers to better integrate with the network and provide their software in a way that makes it more reliable and maybe not faster, but more trustworthy, which is very, very important. Still, it applies only to the solutions that exist, which are mostly centralized. So we have one more important step ahead of us, and it's decentralizing the beast. So, as far as I know, no one has done that yet. We have at least one good idea how to approach this problem. We're going to try to implement it, provide you a document on that, and our estimates on threats and problems, and, well, the environment which should be constructed for this to work, and the parameters which it should hold to work. For example, the probability that a part of network can attack this solution. And once we've done that, we need to prepare a process for software developers to integrate their solutions, centralized ones, with this framework, which we hopefully are going to implement in a way that is very, very easy for them to integrate and seamless for users to use. And I think that's it right now. If you have any questions, you can write emails, or you can ask us right now. Thank you very much.
Yes, and definitely, please do ask questions. This is a Q&A session, so this is the time for this interaction. I can pass you the microphone, please, yes. And if you could give us your name.
So, yeah, my name is Lorenzo, and okay, I wasn't there for the first part, so I might ask something you have already said, hopefully not. My question is, so as far as I understand, jobs in Golem, let's say, I don't know if that's the right term, but something that I want the network to perform for me, they are in a way public, right? It's not possible that I can, for example, like give a task to the network to render something without the network or the people who perform the work to have access to it. Is that the case?
At this point, you cannot, because, well, you can transfer the data in an encrypted way. But so no one on the way can see your data, but at some point you have to decrypt it and render it. So the endpoint is going to see your scene, for example, textures and whatever you have there. Yes.
Okay, any more questions? Someone has any additional questions? No, so, okay, so that's a... Thank you very much, guys.
Okay.
It was an interrupted, indeed, presentation, but thank you for doing it, and thank you for your patience as well. And this is the time, if I could, Philip, if I could.
Thank you.
Thank you. Henry is Streamr's CEO and founder. So, Henry, the floor is already yours, so just take the microphone.
Thank you. Sure. Okay, hi guys. My name is Henry. I'm founder and CEO at Streamr. Thanks to our friends at Golem for having us here, and thank you all for coming here. And hi, Mom, wherever you are. Right. Okay, so here's what's going to happen today. I'm going to explain to you what Streamr is briefly, and then I'm going to tell you the story of how we came to collaborate with Golem and why, and where the kind of complementary technologies meet and what they could do together, and where the overlap is, which gives us synergies for R&D. So let's get started. So Streamr aims to tokenize the value in real-time data. For example, let's take a self-driving car. So to provide the best user experience for the passenger, it constantly needs data from other machines, such as traffic congestion information from other vehicles, electricity prices on nearby charging stations. It's an electric car, of course, weather forecasts, and so on. So Streamr provides a single interface for receiving real-time data and paying for it using a cryptographic token called Datacoin, which lives on the Ethereum blockchain. So basically, this makes data streams tradable by both people and machines. So the car can go, fetch the data it needs and subscribe to it and pay for it. Now, in turn, the car can sell the data it produces, such as traffic information for other cars, road condition measurements to smart cities, passenger blood sugar level to nearby advertisers or whatever. So a data stream economy is born. Streamr is implemented as a decentralized peer-to-peer network. A data source can connect to any node in the network, publish a new data point, and it instantly gets delivered to valid subscribers. The Streamr network scales horizontally up to billions of data points per second, thanks to a clever sharding scheme. The network connects to an underlying blockchain for security-critical operations, such as value transfers and access control. Now, I'd like to make a special note here. So Streamr is designed to operate within the limits of current-day blockchain scalability, right? So but certainly we could do better things with more scalability in the network. We could have more fine-grained control over the operation of the network and the payments, which is why I'm super interested today to hear the talk by Joseph, Thomas, and Vansa about Plasma. That's certainly something that we could use to make Streamr even better. Anyway, decentralization is achieved by allowing anyone to run a node in the network and earn tokens in exchange for bandwidth that they provide to the network. So effectively, the network is run by its users instead of giant corporations, which means you own, control, and monetize the data that you produce. Decentralization also makes the network more robust against attacks and node failures. In addition to the scalable messaging infrastructure, we are also building two applications. The marketplace will allow the data producers and data consumers to find each other, right? So it's kind of like an app store for data streams. And then there's the Streamr engine. So raw data is sometimes not useful by itself, right? It might need computation. For example, combining with other data streams, filtering, aggregating, visualizing, connecting it to blockchains, connecting it to legacy systems or whatever. So this is why we made the Streamr engine. So it ingests data streams from the network and produces some kind of output. And it has a user interface called the editor, which is based on visual programming. So it looks like this. So it allows you to build data processing systems using a visual paradigm and seamlessly combine off-chain analytics and computations with, for example, on-chain smart contracts. It's live, it's up and running. You can go and sign up and try it out. Anyway, so what does this have to do with Golem? Now, I mentioned the word computation, and I told you about the engine, right? So from the start, we knew quite clearly how to build a network, I mean, how to decentralize the network, how to build a decentralized marketplace, but how do we decentralize the computation? Now, if you know what Golem does, they decentralize the computation, right? So we knew that currently they're working on the 3D rendering case, but in their roadmap, they're talking about microservices, long-running processes, and supporting a much broader range of applications that can be run on the Golem platform. So we approached them, and this was the initial idea, to have the Streamr engine running inside the Golem container. So now it's not quite trivial to open network access for this kind of container, since it makes it opens a vulnerability, or it can be used for DDoSing or whatever abuse. So one idea there is to have a gateway, a Streamr client or a Streamr access point, which would have a privilege to open a connection to the Streamr network, and that way provide a safe path for the engine to receive and transmit data. Now, the first realization here is why does it need to be the Streamr engine, right? It could be any application running in there and function in the exact same way, receiving data from the Streamr network, doing something with the data, producing output. Now, the second realization here is that why does the Streamr client need to be the only service layer available in there? I mean, you could have a whole bunch, a toolkit of decentralized services available for your application in there. You could have access to Ethereum, you could have some access to a decentralized database or whatever in there. So this kind of starts to highlight a path for a decentralized service stack for creating applications. Now, today, developers create applications and leverage hosted cloud services to make their job easier. You got virtual machines, you got hosted file storage, you have real-time data pipelines that are centralized, you have analytics, you have microservice engines, you have hosted databases, and so on. Now, here's my prediction. I think each of these layers will be replaced by decentralized counterparts, right? So Golem will steal business from the cloud virtual machine workloads. IPFS and Swarm will start replacing the centralized cloud file storage stuff. Streamr will replace the real-time analytics pipelines and data delivery pipelines available in the cloud. Now, Ethereum and other blockchains, clearly, they're something completely new, right? So there's no cloud counterpart to them, but instead the blockchain actually enables us to decentralize the other layers in the cloud thanks to its uncheatable state transitions. Okay, so in addition to the kind of complementary vision that we can work towards, there's a lot of kind of grassroots level R&D cooperation that we can do. Both projects are thinking about similar problems. For example, both are building their own peer-to-peer network. So we can collaborate on that. Both are thinking about how to assign responsibilities to nodes in the network. The Golem system distributes tasks to nodes. We assign them responsibilities for a certain partition of the data stream. Both are thinking about how to validate the results of computation. Both are figuring out a reputation mechanism for nodes or providers in the network. And also to bring it a little bit more concrete, we're kind of toying around with a few of proof of concept applications out there. Not meant to become products, by no means, but rather guide the development of both platforms. So for example, we have the favorite of Grzegorz there, the decentralized brain, which is a massive spiking neural network running on thousands of nodes performing computations where the neurons would run in the Golem container, and the kind of connections between those neurons would be on the Streamr network. Another proof of concept application idea is to try to replicate, for example, the functionality and usability of Uber. If we can build a decentralized Uber with the same user experience, I mean, Uber is the ride company that doesn't own any cars, but can we build a ride company that is there where there is no company, right? So let's take everything out and leave just the service. Now, the methods in which we can collaborate and are collaborating is, for example, code sharing, sharing of research results, arranging workshops, hackathons, developer exchange. One of our guys can go work with them and vice versa. And of course, engaging the community to think about these things. For example, that's what we're doing right now. So we make your streams come true. Thank you very much. I'd be glad to have any questions
from the audience. Questions time, please. Yes.
Hi. I'm not sure you mentioned something like that, but how do you anonymize the source data?
How do we anonymize the data source? Okay, that's an interesting question. So the network is based on the idea of signing each data point. So basically, we want to know the source of each data because then we can trust that data. So it doesn't take any opinion on what the data content is, right? So you can publish data in there. You don't have to tell who you are. So the identities are, for example, Ethereum identities, and you don't need to bind that to a real-world identity unless you want to, right? So, for example, on the data marketplace, you could have two sellers selling, for example, stock market data fees or whatever, and one of them. So, if as a customer, how do you pick? You know, which am I gonna buy, right? But if the other one identifies them as NASDAQ, you're bound to trust them more. So in that case, identity brings more trust into the system, but you can always remain completely anonymous if you want to. But it's important to be able to prove that a certain data point comes from a certain anonymous identity on the network, which can be accomplished by signing.
Okay, we have time for 2 more questions.
Okay, my name's Andy. I spoke to somebody at Tesla the other day who told me that the cars are driving around gathering data all the time. At the moment, where I assume that data is going to a centralized location, and you gave the example of a car. Now, if Tesla were to switch over to a decentralized system, why would they do that? Like, do you expect them to? What would be the benefits of them to do that? And is that really an application for what you're building?
Yeah, I think so. If you think of how organizations today are thinking about data, all of them are collecting data, but they're kind of keeping the cards close to their bodies. You know, they're not sharing. They're barely using that data internally. Probably not the case with Tesla because they're smart. But most organizations collect data and do nothing with that data. So the data is not valuable to the organization itself, nor is it valuable to anybody else, right? So why would Tesla share the data? Well, they can profit out of it. If the profit is larger than any harm that sharing the data does, then it's like a positive expected outcome from that. Of course, companies might not want to share data that can help their competitors, but there's got to be a price tag for that. So if Tesla were to share that data, like $1 million per day or something, and expect to get 10 customers for that, maybe it's peanuts for Tesla, but who knows? I mean, they might. So it's all about the market economics and what value is in the data for the company itself versus releasing that data. And I think this kind of use cases can emerge. Think about if you had, well, let's take an example of like personal measurement. Would you wear a smartwatch which kind of earns you €5 per day or something? It brings new opportunities to business models to be able to monetize on the real-time data.
Hi, I'm Chris Hobcroft. I'm working on a project called LivePeer, based out of New York, which is a live video streaming platform. Is there collaboration potential here, do you think? It's a sub-case of live streaming. Could your platform take live streaming video?
Yeah. We're concentrating, well, okay. Let's take the kind of technical aspect first. So we don't define the payload of what those events can contain. So it can be binary, it can be anything. But in designing the network, the technical choices we're making are always guided by the idea of the use case that it's some kind of machine data, like sensor measurements or trades coming in from an exchange or something. So it might be possible to do video streaming on Streamr. I wouldn't count that out, but it's possible that we might also have to make some choices along the way that will make it less optimal for that exact use case versus having those, I don't know, IoT measurements going on in there.
Interesting collaborator.
Yeah. We could try what it would mean. Yeah, very cool.
All right, Henry Pihkala, thank you very much.
Okay. Thank you.
CEO and founder of Streamr. And now I'd like to give the floor to Joanna Rutkowska. She's Invisible Things Labs CEO and founder, Qubes OS founder, and an architect, right? Founder and architect. So reasonably secure computing in the decentralized world and operating system architect's perspective.
Thank you very much. So I come from a different world than most of you. I'm a system-level security researcher. I spent several years researching technologies like operating systems, hypervisors, Intel hardware technologies like virtualization technology and other technologies. So, and I have kind of a different perspective on this all. I'm not gonna be talking about networks, network security. I'm gonna look at these problems through my field. So I just need a slide changer.
There it is.
Okay, thank you. So reasonably secure computing in the decentralized world is the topic of this short presentation. So in the 90s, we all heard this buzzword, the network is the computer, right? And just the problem is how to make this global computer secure. And before we move on, I want to just clarify some of the vocabulary. So with adjective secure, there is something like trusted and trustworthy, and occasionally people confuse them and think that all of them are synonyms, which is not really the case. So first is the trusted. Usually we don't like when things are trusted, because when we say that something is trusted third party or trusted computing base, what this really means is that a compromise or a fault of this component really means the compromise of everything, So we don't like when things are trusted. We want to minimize the amount of trusted parts in a system or in a network. Then we have secure, and secure really means difficult to attack. But secure does not necessarily mean that this is good for the user, because, for example, a backdoor might be secure, meaning that it's quite difficult to hijack it by a different attacker, for example. And then finally we have trustworthy, which is something that is secure and good for the user, whatever really good means in this context. We cannot really say what good is objectively, so that will be always contextual. Okay, so here we have this decentralized network computer, and these blue boxes are our applications, processes, or payloads, and we have a user. Okay, so the user has their processes or applications running somewhere in the cloud. This is the vision we have. This is what, for example, Golem is trying to do. Now we have, at least again, from my perspective as a system level security person, there are at least 3 challenges. And challenge number 1 is how to make sure that these blue boxes are actually protected against whoever owns the hardware on which they run. Okay? So if I want to sell my computing power to the Golem network, how do users who will be using my donated hardware, how they can be sure that my hardware is not malicious, or I'm not malicious, and I won't, for example, I will not spy on them, or maybe I will change their programs that run there to do something else. So we have problem of confidentiality and integrity. And this problem, of course, should not be confused with a complementary problem, which is how to protect the host, so computers of people who donate computing resources to the network. Because this problem is actually much more widely researched, and we as an industry have been trying to solve this problem for at least a decade. All these data centers, all the virtual machines that run in these data centers, they are all concerned that customers do not escape from VMs, right? So this is kind of an orthogonal, complementary problem. However, the first problem is the new kind of problem. Right now, if we go and rent a VM in Amazon or somewhere else, we really need to trust Amazon, which means really need to trust their IT personnel. Because the admins can always do anything they want. And obviously, if we now move to something like Golem, which is totally decentralized, we really don't know the people or the companies who manage the hardware on which our payloads are going to be run. We absolutely need some assurance how to eliminate these vectors, right? So that's challenge number 1. Challenge number 2, which I only briefly will mention today, is that, okay, so we have this computer. Let's say our blue boxes are really protected from these people outside. Now, at the end of the day, we access our data through some terminal. This may be a laptop running Windows, maybe a phone running Android or iOS, or maybe something else. Now, the problem is that we can have the most secure network, secure protocols, whatever. However, if our terminal is compromised, then it's all lost from the security point of view, at least, because a compromised terminal can always see all our secret data, because at the end of the day, they always need to be decrypted before they are presented in front of our eyes, right? So on the screen. So if there is a malware on a laptop and the malware has infected a graphics stack, then of course the malware will see all the secrets. So that's a challenge, how to make these terminals actually trustworthy. Some of you might say, okay, but these are just thin terminals. There are no apps running there, so that should be easy to make them secure, right? But that's not quite true. They still have networking stacks. They have USB stacks, because maybe you want to download our slides that we prepared on Google Docs-like application somewhere and to give to a friend or whatever. They have networking services running, and there are other attacks open on these devices. At the end of the day, producing such a device to be trustworthy, secure and trustworthy is quite of a challenge. That was challenge number 2. And finally, challenge number 3 is that when I showed you the original picture a few minutes ago, all the boxes were blue. And I somehow tend to use colors to signalize the level of trustworthiness or security of these components. But in fact, they are not all blue. In fact, they have different colors, so they have different levels of trust. Because some of them might be some maybe games, other might be some Google Docs-like applications where we prepare our sensitive work documents. Yet another ones might be email applications, etc. And one might be a work application, another personal applications, personal email application. So they have different levels of trust. But we said this is all one computer. So a user has a computer, which means there is a large interactions between all these components. Just like today on our Windows or Macs or whatever other devices we have, there's a large interactions between apps. You can exchange clipboard between them, we can send files from one to another, etc., etc. Every such interaction is an attack surface. And so the problem is that if you want to give users something like a computer in the cloud, still we need to solve the problem how to actually make this computer secure. Several years ago, when VDI, virtual desktop infrastructure, appeared on the market, people were really excited. They thought that it was kind of similar, except that we also had thin terminal, and then we had all the computing done in a data center. So people were really excited that this will change the security game, because now, for example, Windows will run in the data center. However, the problem with this is that the same, for example, Windows operating system, when run in the cloud, is not going to be suddenly more secure just because it's been running in the cloud. Still, if there is some email application that we start there, this email application will get an email with an attachment. The attachment will be a PDF file, and the PDF file will try to exploit some bug in a PDF Acrobat reader, whatever. This will again happen in the data center. So here is again the same situation, except that we have many data centers. And here we come to Qubes OS. which is the project that we've been working for almost 8 years now. Right now, Qubes OS is focused on to be a desktop operating system running on laptops. So it has absolutely nothing to do with decentralization and cryptocurrencies. What it does, however, and this is what I'm going to argue, translates one-to-one to what Golem wants to do. So first, what it does currently. Qubes does two things. First of all, it compartmentalizes your desktop computing. So you can define multiple partitions or domains, for example, personal work, accounting, project X, anonymous web browsing, whatever. It's not enforced what the partitions are. Every user, every company can define by themselves. And there are, of course, tools, how to automate it, etc., etc. But this is only half of what we do, or even less than a half, maybe 20% of the effort how to do that. So right now we actually make use of the Zen hypervisor to create such compartments, which are really virtual machines. But most of the effort goes into what we do on top of these compartmentalized compartments, which is the careful integration. Because again, a desktop system is one system. There's one user, one mind, so there must be one system. So all these 15 compartments must be somehow integrated together to present a consistent user system. So this integration of top of compartments is really the main point of most of our efforts. And a trivial example, we have a work email VM where we can have, say, Thunderbird or Microsoft Outlook email client. We get this email with an attachment, PDF attachment. So instead of opening in the same VM, this could be VM or container, whatever, we use a special service that Qubes provides, and the file is seamlessly being transferred to a newly created VM, disposable VM as we call it. Now, in this newly created VM, a PDF viewer, which might be large and buggy and complex, is started, opens the file, presents to the user. When the user is done with it, it closes the PDF viewer, the disposable VM is destroyed. And this all is happening seamless to the user. Now, this looks really simple, but in computer security, usually the devil is in the details, and this is exactly what happens here. There are questions, for example, how to securely transfer file from one compartment to another if they mutually don't trust each other. Again, exposing, for example, network file sharing between VMs is not an option because this is too large an attack surface. So we have special ways to solve that. Another big question is how to virtualize GUI. So we have one VM and then another VM where the PDF viewer runs. How to securely capture what this VM displays and put it on the one common desktop without compromising security.
No, it's fine.
It's fine? Yeah. Okay. So problems like these.
Okay.
Does it work better? Yes. Yeah. Okay. And there are many more problems like this, but this is not time for discussing Qubes architecture today. I just want to stress one thing, that we can see Qubes architecture on 3 levels. First level is this isolation layer, and as I said, currently we use Zen hypervisor. We might also have used or might use in the future KVM or something else. we might use maybe Amazon Cloud VMs. We don't, but we might. Or maybe Golem containers. The idea, at least for a few years now, we have rewritten our stack in a way that this lowest layer should be exchangeable. Because really, the core of the cubes is this green layer here, which we call Qubes core stack, and which really implements, for example, the infrastructure for the inter-VM communication that we believe is significantly more secure than what we could have achieved with standard technologies, GUI virtualization, and of course some policing, etc. And then finally we have Qubes services and applications that are built on top of these, and these are services like, for example, handling this request to open file in a different VM, or to convert PDF from untrusted to trusted, or to use GPG backend, and many, many others. Again, it's not a good time to go into the details. The point is that by exchanging this upper layer from simple Zen on a x86 laptop to something like Golem, which is a computer in the cloud, the centralized computer in the cloud, everything down should remain the same and essentially run out of the box without any modification. So it looks to me that this might be a good application for Golem. So Golem becoming a platform for cubes. And that sounds actually quite exciting. But before that happens, we should also solve the problem number one, the challenge number one that I mentioned at the beginning, which again is how to make sure that our payloads running on untrusted hardware can be secured from the untrusted hardware. This is really absolutely required here, because obviously if we are talking about running my computer, moving my computer, my Mac or my Windows to the cloud, it's really required that confidentiality and integrity be provided for all the payloads. It's not enough. This can't be solved with any kind of statistical network level security. This must be solved on CPU level security. And as a matter of fact, one of the first areas of our cooperation is to actually try to approach this problem. So that's the long-term vision of Qubes and Golem. And if you have any questions, it's a good time now.
But reasonably secure computing in the decentralized world. I'm sure you have questions to Joanna. Yes, please.
Hi. As a user, will it be anonymous?
As a user,
or can it be? Can any data be tracked if I'm using it?
That's a question which is hard to answer, because it would depend on how specifically Golem would be implemented. From the Qubes OS perspective, in this vision that I presented, we expect that Golem will expose us some kind of API similar to, say, OpenStack or API used for EC2 management or any other virtualization system. Now, will this API allow, and will the infrastructure allow for anonymous use of computing power? That's really the question for Golem people, not me. I don't see right now anything in this Qubes part of the architecture that fundamentally would prevent that. Okay.
How does a user interface with the operating system?
Through this trusted terminal, that was problem number 2, how to solve, which was, sorry for jumping. That was this red thing here. This is your trusted terminal. Maybe this is your iPhone. Maybe this is your Windows computer with a browser. I don't really recommend that option. Or
It's an app, or it's a browser, or it's a...
again, it might be an app, but for users who really want more security, that might be a specialized terminal that would also be resistant to, say, evil mate attacks or secure boot bypassing attacks, or maybe this will be a Qubes laptop because it will have isolated Wi-Fi stack, etc. Again, different kinds of users will settle for different solutions, I imagine.
Hi. You mentioned for a while CPUs, and previously on the Golem presentation there was a mentioning of machine learning. And right now machine learning works really fast. It gets accelerated very well on GPUs. Is it possible to isolate GPUs as well with Qubes OS, and maybe even, I don't know if this is even possible right now, tensor processing units? I don't know.
Okay, so that's a very complex question because these are really two questions. First question was, is it possible to securely virtualize GPU, as I understand? The answer is probably yes. Some GPU cards, like Intel GPUs, they do have special hardware provisions for virtualization or multiplexing. We don't have support for that in Qubes yet, but there are some projects, ongoing projects, more like research projects, but they are, for example, supported by Intel, like Zen GT, that try to do that. But even more tricky question is, can we use GPU on untrusted hardware and still protect from this untrusted hardware? This is even more complex question to which I'm not able to answer at this moment.
Okay.
Okay, thank you.
Thank you very much, Joanna. Thank you. And now I'd like to ask you to listen to our summary of what has been said in Henry's speech and Joanna's speech. Grzegorz Borowik is our senior software engineer. So please, Grzegorz, the floor is yours.
Yes, so thank you for introducing me. And I would like to sum up this, guys, what it was said here. So I will deliver here a metaphor what Golem is and how we may understand Golem. So thinking about our cars, we know that they are stuck at the parking lots most of their lifetime. So Golem is to bring computers to the life. And even our cars are in traffic. Usually there are still one guy in the car, it is a driver. So we may imagine that we usually run one program on our computer, but assuming that it requires more computational power, the nicest thing that may happen is to delegate this task to the other computers. So I think it can be only done in a collaboration with these guys as Streamr and Joanna. So as Henry said, these technologies are somehow complementary to each other because computations cannot be done without the data, and they know how to deliver this data. And on the top of this collaboration, there is a Joanna. She is going to make this system safe and secure. And our vision is that user in the future will take this system and we'll have the problem done. So we'll delegate the data and have the problem solved. Thank you.
Thank you. Thank you very much. Yeah, okay. All right, guys, I know we already had a break, and it was quite long. It should be quite shorter, but let's take another one, much shorter, 5-minute break. We're going to continue with our meetup. That concludes this part that's been called Golem, Plans, and Friends. But of course, it doesn't mean that in this other section, in the second section, we are not going to listen to our friends. Yes, we are. Please stay tuned, and please come back to the audience, and we're going to continue with our meetup. Thank you.